Welcome to the Astronomy channel. In this video, we will talk about the Hubble Space Telescope's latest images. This image from the Hubble Space Telescope shows two of the galaxies in the galactic triplet ARP 248, also known as Wild's Triplet, which lies around 200 million light-years from Earth in the constellation Virgo. The two large spiral galaxies visible in this image, which flank a smaller, unrelated background spiral galaxy, appear connected by a luminous bridge. This elongated stream of stars and interstellar dust is known as a tidal tail, and it formed by the mutual gravitational attraction of the two foreground galaxies. This observation comes from a project which delves into two galleries of weird and wonderful galaxies, a catalogue of southern peculiar galaxies and associations, compiled by astronomers Halton Arp and Barry Mador, and the Atlas of Peculiar Galaxies, compiled by Halton Arp. Each collection contains a menagerie of spectacularly peculiar galaxies, including interacting galaxies such as ARP 248, as well as one- or three-armed spiral galaxies, galaxies with shell-like structures, and a variety of other space oddities. Hubble's advanced camera for surveys scoured this assortment of eccentric galaxies in search of promising candidates for future observations with the NASA's James Webb Space Telescope, the Atacama Large Millimeter/Sub-Millimeter Array, and Hubble itself. With the wealth of astronomical objects to study in the night sky, projects such as this, which guide future observations, are a valuable investment of observing time. The Hubble Space Telescope's Wide-Field Camera 3 imaged this lonely spiral galaxy called UGC 9391. The galaxy resides 130 million light-years from Earth in the constellation Draco near the North Celestial Pole. Its star-studded spiral arms stand in splendid isolation against a backdrop of distant galaxies, which are only visible as indistinct swirls or smudges thanks to their vast distances from Earth. The image also features some much brighter foreground stars closer to home. These bright nearby stars are ringed with diffraction spikes, prominent spikes caused by light interacting with the inner workings of Hubble's secondary mirror supports. This image is from a set of Hubble observations which astronomers used to construct the Cosmic Distance Ladder, a set of connected measurements that allow astronomers to determine how far the most distant astronomical objects are. Astronomical distances are only directly measurable for relatively nearby objects closer than 3,000 light-years or so. For distances beyond this, astronomers rely on a set of measured correlations calibrated against nearby objects. UGC 9391 helped astronomers improve their distance estimates by providing a natural laboratory in which to compare two measuring techniques: supernova explosions and Cepheid variables. Improving the precision of distance measurements helps astronomers quantify how quickly the universe is expanding, one of Hubble's key science goals. Two interacting galaxies making up the pair known as ARP Mador 608 to 333 seem to float side by side in this image from the Hubble Space Telescope. Though they appear serene and unperturbed, the two are subtly warping one another through a mutual gravitational interaction that is disrupting and distorting both galaxies. Hubble's advanced camera for surveys captured this drawn-out galactic interaction. The interacting galaxies in ARP Mador 608 to 333 are part of an effort to build up an archive of interesting targets for more detailed future study with Hubble, ground-based telescopes, and the NASA's James Webb Space Telescope. To build up this archive, astronomers scoured existing astronomical catalogs for a list of targets spread throughout the night sky. They hoped to include objects already identified as interesting and that would be easy for Hubble to observe no matter which direction it was pointing. Deciding how to award Hubble observing time is a drawn-out, competitive, and difficult process, and the observations are allocated to use every last second of Hubble time available. However, there is a small but persistent fraction of time, around 2 to 3%, that goes unused as Hubble turns to point at new targets. Snapshot programs, such as the one which captured ARP-MADOR 608 to 333, exist to fill this gap and take advantage of the moments between longer observations. Snapshot programs not only produce beautiful images, they enable astronomers to gather as much data as possible with Hubble. If you enjoyed this content, like, share and subscribe the channel. Thank you for watching.